Arshad Mansour, who is the president of Electric Power Research Institute, and he is responsible for the Institute's operation and portfolio of research and development programs. He's been with EPRI 21 years, and he served as Senior Vice President of Research and Development and Vice President of Power Delivery and the Utilization Sector. Mansour holds 5 U.S. patents in power electronics and distributed energy resources. He's a senior member of IEEE and served as the VP of the United States U.S. National Committee of CIGRE, and he's a member of the Board for Energy Production Infrastructure Center at University of North Carolina at Charlotte. He has his BS in Electrical Engineering from Bangladesh University of Engineering and Technology and an MS and doctorate in Electrical Engineering from the University in Texas. He's also completed the MIT Reactor Technology Course and Harvard Business School Advanced Management Program. As an energy thought leader, he has been an outstanding spokesperson in the field of electric power and all of the complexities associated with it. And he's been widely quoted and taught at national levels and has been appeared in the global press and presented in a variety of fora worldwide, including board briefings. He's published numerous papers in journals and conference proceedings, and we're honored to have him here. So welcome, Arshad, and looking forward to hearing you and seeing your thoughts. And I know you have some slides for us, which we're very enthusiastic to see as well. So Arshad, please take it from here, and we look forward to it. Thank you so much.
Thank you, Sheila. Thank you. It's an honor and pleasure to be here today. I want to share some of the work that we're doing at EPRI with our members, with our partners like GTI, on what is a thoughtful way to transition to a clean energy future. But before I share my thoughts, let me just pause and just say that we'll miss Barry. Barry has been a larger-than-life influence in the global energy arena. Barry was a visionary, but he was a pragmatic visionary. He knew the need for clean energy for the world, but he also knew that we need to do this thoughtfully, reliably, affordably for all the people in the world, some of whom don't have access to any energy form. So with that in mind, I thought it would be appropriate for me to talk about some of the work that we have done over the last, I would say almost a decade, to look into not just the electric sector, but the transportation sector, the buildings, the industry, and see what is a thoughtful way we can transition to a clean energy future. We call that our Project 2X 2050. Let me make sure I can advance the slides. It's a busy slide, but this is just one slide, an infographics that really captures a lot of work we have done based on our labs, based on working with our partners. And really what it's talking about is what is the technology pathway to accelerate our clean energy future, to get there net zero, not just electric sector, across all the economy, transportation, buildings by 2050, or maybe even sooner. If you look at this infographics, on the top, you'll see 3 quadrants. The left one says US energy related CO2 emission. The middle is what we call the tools in the toolbox that will help us to get there. And then the right is what the electric sector is doing. And at the bottom, you will see 2 other segments. That's the technology pathway for the next decade. And on the right is the technology pathway all the way to 2050. So before we look at what is the technology pathway that our research is illuminating, it's actually good to look at the past and see what we have done in US. This is a US focused infographics. So if you look at the top left, the US energy related CO2 emission bar, our emission in 2005 related to energy production, delivery, and use was approximately 6 gigaton per year. Electric sector was the largest emitter at 40% of those 6 gigaton came from the electric sector, and then transportation, and then industry and buildings. So that's 2005. Let's come to today, 2020. But let's go to 2020 January, not this unfortunate event that we are seeing globally and the economic impact. But if you look at 2020 January, we have been able to reduce in US that 6 gigaton emission to 5 gigaton. And if you look at the way we did that, it was primarily through the electric sector. So in 2020, today in January, electric sector is actually not the highest emitter, but transportation is. And if you look at the right side quadrant, how much cleaner electricity has become, almost 30% cleaner from 2005 to 2030, at 2005 to 2020. And this contribution that the electric sector made primarily came from almost 2/3 of that was using natural gas, coal to gas conversion. 1/3 of that was new wind, new solar, as the price of renewables going down. But important to keep in mind that we were able to mostly keep all the nuclear plants operating, not all of them, but mostly, and that's the largest carbon-free energy that we have in US today. And if you look at globally, the global emission actually went up from 2005 to 2020. There were 40 countries that reduced emission. US was one of them. And US contributed to more than half of the emission reduction. But one of the most important factors that you don't see in the slide is during this last 15 years, our economy grew, but the retail price of electricity that consumers pay, inflation adjusted in real dollars, really remained essentially flat. So going from 6 to 5, mainly using cleaner electricity, and if you look in the middle, energy efficiency is always the first resource that we use. But we use two tools in our toolbox: energy efficiency, cleaner electricity, to get from 6 to 5. Do that affordably. Now we paused and we looked at what can we do in the future? What can we do in the next 10 years? What can we do in the next 20, 30 years? And the way we do this is we have a comprehensive energy system modeling tool that is informed with the research that we do across different technologies to see how technologies will progress in the next 5, 10, 15, 20 years. And if you look at the technology progression and the cost reduction, what is a reasonable estimate? And we looked at 2030, 10 years, that's the next decade. And we think that we can get to 4 gigawatt, 5 to 4 in 10 years. So it's almost a 50% acceleration. And we can do that. We still got to do energy efficiency. That's the best resource for our consumers. We have to clean electricity. There will be more coal to gas. There absolutely will be more renewables. But we need to make sure that the largest source of clean energy, nuclear, stays online. But we'll have to bring a third tool in the toolbox. And that third tool you see in the middle is efficient electrification, especially on the transportation sector. So that 5 to 4 progression, we think we can do thoughtfully, reliably, affordably. In addition to energy efficiency and cleaner electricity, if you look at the bottom left, there are some new technologies that this industry will need to deploy at scale. Our model is showing that we'll need approximately 30 gigawatt of flexible resource, 2 to 4 hours. Some will be batteries, some will be flexible demand enabled by grid modernization. That's a big amount. That's the amount of hydro that we have today that took us decades to build. Our model also shows that we will be reaching cost parity over the next 3 to 4 years on electric vehicles and gasoline vehicles. And in 2020, 4 out of 10 new cars could be electric. And it's the first time we have an opportunity. If you look at an average US customer, $45,000 annual income for a residential household, almost 10% of that $4,500 is their energy bill. The energy bill is gasoline, electric, and gas. If EV reaches cost parity, not if, when, and if we replace with EVs, that customer, that residential household, could actually reduce $1,000 their energy bill. But we need infrastructure for charging that is widely available, not just for the upper income people, but for in disadvantaged communities, in places where your average residential neighborhood is. And this will require significant amount of charging infrastructure. It's almost like 1936 when we made a decision that electricity is good for all. and we need to do rural electrification and get electricity all the way down. As EV reaches cost parity, we need to make a focused effort like that. So in addition to flexible resources, we've got EV charging infrastructure. We are allowing to a cleaner energy transition and actually reducing the energy cost that a customer pays. That's the first time we can do that, and cleaner transportation enables us to do that. And then we paused, and then we say, okay, how do we go beyond 2030? How do we go to low to no? And when you say low to no, it could be 0 ton, it could be 0.5 gigaton, but a low to no carbon future. And that's where we came up with the realization that even if we do energy efficiency, keep on bringing more renewables, add nuclear, and we are electrifying now buildings and transportation, even with that, we will not be able to go to net zero or even close to net zero across the economy. And that's where we need alternate energy resources, the low carbon resources, hydrogen, liquid ammonia, synthetic fuel, biogas. And one of the opportunities is we could actually use the clean electricity grid and use clean electrons to produce clean molecules. And that's really what the genesis of what we launched earlier this month, partnering with GTI, Gas Technology Institute, the Low Carbon Resource Initiative. It's a moonshot that the industry is undertaking so that in this decade, while we are deploying EVs, while we are deploying batteries, bringing more renewables, keeping our nuclear fleet operational, we're also doing the research. So we're looking at advanced nuclear. We're looking at electrolysis. We're looking at how new molecules like hydrogen and liquid ammonia could clean the transportation sector, the shipping sector. We're looking at how the natural gas infrastructure that we have in US could be carrying maybe initially a blended fuel, natural gas and biogas, natural gas, biogas, and hydrogen. So natural gas has been a key ingredient over the last 15 years to go from 6 to 5. It will be a key ingredient, key molecule from going from 5 to 4. Industries will be replacing crude with natural gas as their raw material. There will be more coal to gas conversion, but we'll need something, another molecule as we start looking into zero carbon future, a low to no carbon future. And that's what LCRI is going to do. It's a 5-year initiative. We are excited with, it just started. We have almost 20 entities, gas companies, electric companies, technology providers, GE, Mitsubishi, that are part of it. Our goal for the moonshot is we will, through coordinated research, development, and demonstration, advance technologies that will help us to take the electric sector, maybe from 70, 80% to 100% clean, but it will also take the transportation sector. It will also take the buildings and industry, where you really can electrify everything, but you have other resources, other low carbon resources that will help in the decarbonization. I'm very excited. You'll hear from David Carroll from GTI about this LCRI initiative, but we will keep USEA and all the USEA members posted on this 5-year initiative as we take this journey. So with that, let me hand it back to Sheila. And Sheila, once again, we will miss Barry. I am honored to continue the legacy of this USEA Technology Advanced Forum and appreciate you inviting me to speak.
Well, it's wonderful to have you, Arshad, and the way that you have set the stage for a variety of sectors of the energy industry is very useful, because I think these are the things that everyone is struggling with, and your leadership means a huge amount to us, and we're delighted to hear from your standpoint. I don't know if there's any questions yet. I haven't seen any yet, but why don't we give it a minute? Can you stay on for a few moments if there are any?
Sure.
Thank you so much. Arshad, what do you see as the biggest challenge while we're waiting? I'll just kick off a question right now. What is it that keeps you up at night? Is it environment? Is it cybersecurity?
I think as we look at the energy sector going forward, I think cybersecurity, physical security, but overall resiliency, how resilient the energy system is, both in terms of we will see weather patterns. Even if we are at net zero, we are accumulating greenhouse gas emission, and that will change. Weather patterns will become more severe. Digitalization will be pervasive in the energy sector, which means cybersecurity will be of paramount importance, but also physical security. So I think as we are transitioning to a low carbon future, we almost have to make a similar transition to a more resilient energy future. And I consider that as the other side of the coin. One side is mitigation, another side is resiliency and adaptation.
How do you combine those two?
So that's where both will require investment. Both will require significant investment. And what we see is, and we want to make sure that energy remains affordable. So we see a third block. It's almost a three-legged stool. The digital transformation of the energy system will help us to reduce some of our O&M cost and actually give us some headroom so we can invest both on resiliency and on the mitigation. But it has to be done thoughtfully because energy has to remain affordable for the masses.
What do you do to encourage countries that are just in the process of really building their economies, and so their adherence to international goals and standards may not be as sincere or as well funded as they need to be to reduce overall emissions?
Great question. And my background, I was born in Bangladesh. You can consider Bangladesh as one of the countries which the growth rate is now 7-8% economy growth, which US had in 1950s, 60s. Energy is not available. Electricity is not available for a lot of people there. There's 1 billion people in the world that doesn't have electricity today. There are more people in the world that doesn't have electricity than the number of people that was there before Edison invented light bulb. And how do we get energy in a country like Bangladesh with not a lot of space for wind and solar, no natural gas infrastructure? We need to look at all energy resources, but we can do it better than what we did in 1950. We can do it much more efficiently. So I think as we go through the transition, every country will have its own starting point. The good thing is we now have a lot more technologies available today than we had in 1940s or 1950s. And the transition, deforestation and using wood to burn and heat your home will not improve our climate. And electricity and form of energy is going to be critical to available to the masses.
Well, thank you. That's a particularly profound observation. And the question is, how do we make that happen? How do we provide the funds necessary to provide energy as a human right, while at the same time recognizing that a clean environment is a human right too? So that's the challenge. So Al or Will, do you see any questions that have popped up?
Yes.
I have not seen. Yes,
there are a couple questions. One question is, can you talk about the co-benefits of focusing on reducing CO2? You get tremendous reductions in NOx, SOx, mercury, smog, and other pollutants when you squeeze out carbon, correct? The health benefits for the American people from those reductions are enormous.
Absolutely, brilliant question. I should have addressed that. That's really what we see. We now have clean air. We can see clean skies, but we did that through destruction of the economy. We shouldn't do that. What we do is we go to a clean energy future and we get cleaner air, we get cleaner skies. Air quality is directly responsible for that in especially disadvantaged communities. So the co-benefits, and another big co-benefit, which when we think of energy poverty, we only think of natural gas and electric bill. But for developed countries like US, we have more cars than people. So gasoline bill is also our energy cost. we now have an opportunity to actually reduce that energy cost. You know, $4,500 for somebody who earns $45,000 is 10% of their income. If you can reduce that by $1,000, by $800, that's a lot of money. So I think another co-benefit for going to a cleaner energy future, if we do it thoughtfully, is actually reduce the energy cost for the customers.
We had a second question. The California fires are putting more carbon into the air than all of the California emissions for an entire year. Add the Australian and Amazon, other massive fires, and this will get worse. What can be done as soon as possible to stop this vicious cycle of climate change?
Well, a great question. We do research on the energy side. So how we produce energy, how we transport energy, how we use energy. We got to do everything that we can and do it in an expedited way, but do it thoughtfully to reduce the greenhouse gas accumulation in the atmosphere. But that's not the only source. There are other industries, there are nature conservation agencies that will come in, and we'll have to manage the whole ecosystem. While at USEA and at EPRI, we're focusing just on the energy side, but I think the entire ecosystem of climate management, climate adaptation would be critical for us to get to a low to no carbon future across all form of energy and the economy.
Well, thank you so much, Arshad, and thank you for your time and for that brilliant presentation. And you've given us food for thought and a great kickoff for the rest of our discussions. Thank you so very much.
Thank you.